So we've looked at waves here. Let's look at the concept behind just the physical property of a wave into more the idea of a wave. We call this a wave form, and it's an incredibly useful concept in both science and math. What's really nice about these is that you can investigate them from a really simple level of math and science. So it's pretty easy for anyone from 13 to 15 to look at them. But you can also investigate them with higher order mathematics, like a lot of tools that you can find in calculus. And so the concept of waveforms is one that you'll be able to investigate in different ways throughout your school career, which I think is fantastic. I think it's fun, and it's got a lot of depth in how we investigate movement in energy, because that's what a wave really is. It's how energy moves over time. And so we saw that here. We basically had three frames. It's like if we took a snapshot, a picture, 1, 2, and 3. Well, this would be happening over time. So what are the different parts of this wave? Well, waves are really moving in two directions. They're moving this way, the energy travels this way, but the actual physical particles that are allowing the energy to travel are moving up and down. So that up and down motion, this motion right here, this up and down, this distance here is called the amplitude. So that's one of the terms that we're going to need to know. It's very important to know this term. Another very important part of a wave is this distance right here. Notice these waves repeat themselves. So this is one wavelength, this is a second wavelength. These should be identical. So we call this is wavelength, just like I said. Now, amplitude and wavelength, when we're talking purely mechanical properties, are both measured in lengths. So they're measured with meters or inches or feet or miles, something like that. We're going to be doing all of our measurements in meters when we care about them. So this could also be meters. Depending on what type of wave you're looking at, this amplitude might not be meters, it might be something else, but it's really going to be this kind of back and forth vibration. The wavelength is always going to be a length, though. It's always going to be a distance. So what else? What else are we looking at? Well, if we think about it this way, we think about this is moving over time. How quickly is this moving? So we can think about how long, how large is one of these wavelengths, but also how quickly is this wave moving? In other words, how many waves are moving through this space each second? So it's like if I've got a space like that, how many of these waves move through that space every second? And so we call that, when we're talking about waveforms, we call that a cycle per second. And the measurement for cycles per second is hertz. You may have heard this. Hertz is a measure of frequency. And we're going to look at this later more specifically, but for those of you who play instruments, when you play a certain note, what you're doing is you're vibrating air at a certain frequency. That note's identity is actually a very specific number of hertz. Like 220, I think, is I want to say A3 or A4, A2. It's an A. It's an A note. So these waveforms are really going to play a huge part when it comes to sound, specifically music, and light. So we need to know these three terms: amplitude, wavelength, frequency. Now, these waves have these different parts that we'll label, but we don't really need to remember them super specifically. Amplitude, wavelength, and frequency are going to be the big three that we definitely need to know. But otherwise, we've got these peaks right here. We call these crests. So this is a crest. And we've got these valleys here, and we call these a trough. It's less important to remember these, but we should still know them. So if I say crest at any point, I'm saying the crest of the wave, I mean the top part of the wave. If I say the trough, I mean the bottom part of the wave. Okay?